Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, now we're gonna solve question number 21 of this question paper. Okay, we're gonna solve question number 21 of this question paper. So let's get started. So fellas, in this question, a reaction scheme of benzene is given. So at first, let us study the reaction scheme and revise some of the things that we have learned earlier. Okay, so at first let us read the question. Compounds derived from benzene have many uses, including as dyes and drugs. Sudan 1 is an intense orange red azo dye that is used to color waxes, oils and polishes. It can be prepared from benzene using the reaction scheme shown. Okay, so in here it is benzene. So in here the reaction scheme is given. Okay, so it can be prepared from benzene using the reaction scheme below. So the reaction scheme is given over here. So at first, before going to the question, let us study the reaction scheme that is given over here. Okay, so in here it is the benzene. The first compound is benzene. So under certain condition we gonna have nitrobenzene. So in the first part of the scheme we want to make benzene, we want to make a nitrobenzene from benzene. So in the first part of the scheme of this reaction scheme we want to make nitrobenzene from benzene. So for that the condition is concentrated nitric acid, concentrated sulfuric acid, and temperature is 55 degrees Celsius. Okay, so at first let us discuss this part of the scheme of the reaction scheme. Okay, so in here these two reagents are called nitrating mixture. So you can guess from this name that this is nitration of benzene. Okay, so in a nitration of benzene we use the nitrating mixture, which is concentrated nitric acid and sulfuric acid. We mix at first we mix these two concentrated acid together at 55 degrees Celsius and nitrous acid is formed. Then we add benzene and the nitrous acid react with this benzene to form nitrobenzene. Okay, so this whole process is called nitration of benzene. Nitration of benzene. So this is called the nitration of benzene. So in the step 1 we are carrying out nitration of benzene. So in here we have nitrating mixture, which is concentrated nitric acid, concentrated sulfuric acid. These two are the nitrating mixture. Okay, so benzene react with this nitrating mixture, or in other words we can say that benzene reacts with nitrous acid to form nitrobenzene. So we're gonna look in details in the later question. Okay, but for the time being let us know that this is the nitration of benzene, where we can form nitrobenzene from benzene. Okay, so now let us study this nitrobenzene. So what type of compound is this? This is aromatic. This is also called aromatic nitro compound. Okay, so this is also called aromatic nitro compound. Okay, so this is also called aromatic nitro compound. Okay, so nitrobenzene is the aromatic nitro compound. So in here this is also called aromatic nitro compound. Okay, so well, this is the first part of the reaction scheme. Let us move on to the second part, or or step 2 of the reaction scheme. So in the step 2, in step 2 we can see that we have converted nitrobenzene to phenylamine. Okay, so for that we need to carry out the reduction of nitrobenzene. Reduction of nitrobenzene. Sorry for my handwriting, fellas. I know my handwriting is really bad, but please understand this thing by yourself, okay? Since my handwriting is really bad, okay? Okay, by the way, so reduction of nitrobenzene. So in the step 2, since we are converting nitrobenzene to phenylamine, so the only possible reaction for this conversion is reduction of nitrobenzene. So if we carry out reduction of nitrobenzene, then we can form phenylamine from nitrobenzene. Okay, so now let us discuss the reagent that is required for this reaction. So the reagent that is required is tin and concentrated wait a minute. Well, fellas, let me zoom this a little bit, then it should be fine. Okay, so yeah, okay, so in here in step 2 we are carrying out reduction of nitrobenzene. Okay, so in order to carry out the reduction of nitrobenzene, we need two reagents. One is tin and another one is concentrated HCl. That's it. So for step 1, in step 1, let us review the whole thing. Okay, these two steps. Now let us review step 1 and step 2. Okay, so in step 1 we have carried out nitration of benzene. So for that we need nitrating mixture, which is concentrated nitric acid, concentrated nitric acid and concentrated sulfuric acid, okay, at 55 degrees Celsius. So this is nitration of benzene. In here in step 1 we have formed nitrobenzene from benzene. So in other words we can say that nitrobenzene is aromatic nitro compound. Okay, and in step 2 we have carried out reduction of nitrobenzene in order to form phenylamine from nitrobenzene. So since we are forming phenylamine from nitrobenzene, so we have carried out reduction of nitrobenzene. Okay, and the condition for this reaction is tin and concentrated HCl. So therefore the reagents for this reaction is tin and concentrated HCl in order to convert nitrobenzene to phenylamine. Okay, so in other words this can be said that this reaction is the preparation for aromatic amine. Okay, so phenylamine can be also named as aromatic amine. Okay, since it has a benzene ring, so any benzene ring compound we can say aromatic compound. Okay, this is aromatic nitro. In here we have classified is in here we have classified this as aromatic nitro compound. So in the same manner we can classify this thing as aromatic amine. Okay, preparation for aromatic amine. Okay, So in other words, reduction of nitrobenzene is the reaction for preparation of aromatic amine. Okay, so you may say that why this is a reduction reaction. That's because we have lost oxygen and gained hydrogen. Okay, so in here we can see that hydrogen is added, hydrogen is added and oxygen is removed. So in that manner we can say that this is a reduction reaction is removed. Okay, all right. So this is the reaction scheme so far. Okay, so far we have formed phenylamine from nitrobenzene. So now, okay, let's check whether I have missed anything or not. Okay, this is the preparation of aromatic amine. Okay, by the reduction of nitrobenzene. The conditions are tin and concentrated HCl. So in here we are forming phenylamine from nitrobenzene, which is also an aromatic nitro compound. Nitrobenzene is aromatic nitro compound. Okay, so why this is a reduction reaction? That's because hydrogen is added and oxygen is removed. Fine. So now let us move on to the third step of this reaction scheme. So in here the main objective of this scheme is the main objective of this reaction scheme is to form red azo-dye from benzene. So we want to synthesize azo-dye from benzene. Okay, so that is why we have been through a lot of process, a lot of steps. It requires a lot of steps. Okay, so now let us move on to the third step. So in here we are forming Benzenediazonium chloride from phenylamine. Okay, so in the third step we are forming Benzenediazonium chloride with phenylamine, and these are the reagents: sodium nitrite, hydrochloric acid, dilute hydrochloric acid, and the temperature is between 0 degree Celsius to 10 degree Celsius. Okay, so here basically phenylamine reacts with nitrous acid to form Benzenediazonium chloride. Okay, so basically phenylamine reacts with nitrous acid to form Benzenediazonium chloride. Okay, so now the question is, where does this nitrous acid come from? Just as before, we have learned that we need to prepare something. From here we have mixed this with this to form something, nitrating mixture. From nitrating mixture, the same as before, in here we need to form nitrous acid. Since nitrous acid is unstable, we need to prepare it immediately. So how am I supposed to prepare this nitrous acid? Just by reacting sodium nitrite with HCl. That's it. So by mixing these two reagent, we gonna get nitrous acid. Okay, I know that unit 5's organic chemistry is little bit complicated, but still we need to manage that thing. So this is how we gonna do. So let us recall this once again. So we want to synthesize Benzenediazonium chloride from phenylamine. For that we need nitrous acid. Okay, so in order to make nitrous acid, we need to mix sodium nitrite with HCl with phenylamine, then we gonna get Benzenediazonium chloride. Okay, so these are the reagents for this reaction. and the condition is this. Okay, so in the third step we have converted phenylamine into benzene diazonium chloride. Okay, in the third step we have converted phenylamine to benzene diazonium chloride. So the conditions for this reaction is we need reagents sodium nitrite HCl, and condition is 0 to 10 degrees Celsius. So why do we need these reagents? That's because to form nitrous acid, which is unstable at this certain temperature, above this certain temperature. So that is why we need to prepare nitrous acid. So for preparing nitrous acid we need these two reagents. Okay, then this nitrous acid will react with phenylamine, then this nitrous acid will react with this phenylamine to form benzene diazonium chloride. Okay, so far so good. So now let us briefly study the structure of this benzene diazonium chloride. Okay, so the structure for this benzene diazonium chloride is this. So this is the benzene ring. I know I can't draw perfectly, my drawing is really bad as well as my handwriting, really sorry for that fellas. We N2 plus Cl minus. Well fellas, here you go, the structure for benzene diazonium chloride. So this is the benzene ring actually, having N2 plus over here and Cl minus, and in the next video we're gonna discuss in details about this structure, so we're gonna leave it for that. Okay, so let's move on. So this is the structure, this is the basic structure of benzene diazonium chloride. Okay, so now let us move on to the fourth step. So in the fourth step let us actually see what is happening. In the fourth step we have converted benzene diazonium chloride to Sudan 1, which is an azo dye. Okay, azo dye, azo dye. Okay, I can't pronounce this thing perfectly, how am I supposed to teach you? Okay, by the way, let's just leave that aside. Okay, benzene diazonium chloride, benzene diazonium, in here we are converting benzene diazonium chloride into azo dye, which is Sudan 1. So here we are converting benzene diazonium chloride to azo dye. So the condition for this reaction is condition is applied condition dilute sodium hydroxide. Okay, so condition is dilute sodium hydroxide. Okay, so under alkaline condition we need to give the reagent. Which is the reagent? Phenol. Okay, basically benzene diazonium chloride will react with phenol or its derivatives. Okay, or not of. Or its derivative. Okay, not derivation, derivative. Okay, I am wasting so much time fellas. Oh, the exam is near but I couldn't able to complete the whole question. That's the whole agony of my life. That's the main failure of my life. What should I do? Okay, so in here we want to convert benzene diazonium chloride to Sudan 1, which is azo dye, a type of azo dye. So the reagent, the main reagent that we need to do, the main reagent that we need to give is phenol or its derivative naphthol, phenol. Okay, so in here, basically here naphthol is given. Naphthol is reacting with benzene diazonium chloride to give this weird structure. Okay, so the main reagent is phenol or its derivative that is reacting with benzene diazonium chloride to give azodine, and this dilute sodium hydroxide is just a condition. Okay, alkaline condition. Okay, alkaline condition. So under alkaline condition, we are applying benzene diazonium chloride with we are reacting under alkaline condition, we are reacting benzene diazonium chloride with phenol or its derivative to give azodine. Okay, so that's pretty much it. So that's the whole discussion of this reaction scheme. Okay, let me see, do I left anything? Okay, pretty much not. Well, that's it. Now let us once again review this whole thing again. I know that it's been a lengthy video, but still we need to do it in details. Okay, so in here we want to prepare azodine from benzene. So we want to synthesize azodine from benzene. So azodine from benzene. So we want to synthesize azodine from benzene. That's it. So in here, first we want in here, in the first step, in step one, we have carried out nitration of benzene. Okay, we have carried out nitration of benzene. In step 1 we have carried out nitration of benzene. So what is actually happening here, we have given the reagents concentrated nitric acid and concentrated sulfuric acid at 55 degrees Celsius, which is acting as nitrating mixture. So benzene will react with this nitrating mixture to give nitrobenzene. Okay, so this is the nitration of benzene. So in here nitrobenzene is aromatic nitro compound. Okay, so now in step 2 we want to carry out so we want to carry out preparation for aromatic amine, or we want to prepare phenylamine, which is also an aromatic amine. So in step 2 we want to prepare phenylamine, okay, which is also an aromatic amine. Okay, so for that we need to carry out reduction of nitrobenzene. So we need to reduce this nitrobenzene. So if we reduce this nitrobenzene, we gonna get phenylamine. Okay, so for that we need the following reagent, which are tin and concentrated HCl. So in order to carry out reduction of nitrobenzene, we need tin and concentrated HCl as reagent. Then we gonna get phenylamine from nitrobenzene. Okay, so here why we have carried out the reduction of nitrobenzene, that's because for the preparation of aromatic amine. Okay, so why this is a reduction reaction, in here hydrogen is added and oxygen is removed, that is why. So in the third step, okay, let us move on to the third step. We want to prepare benzene diazonium chloride from phenylamine. So for that we need nitrous acid. So phenylamine reacts with nitrous acid to give benzene diazonium chloride in step 3. In step 3, phenylamine reacts with nitrous acid to give benzene diazonium chloride. Okay, so the reagents for the following reaction is sodium nitrite and HCl. Okay, these two react together. This sodium nitrite and HCl react together to give nitrous acid, which later react with this phenylamine to give Benzenediazonium chloride under 0 to 10 degrees Celsius. Okay, so why we need to give these two reagents? That's because nitrous acid is unstable at room temperature, so that is why we need to prepare in order to synthesize in order to make Benzenediazonium chloride. Okay, so in step 4 we want to create azodye from Benzenediazonium chloride. In step 4 we want to create azodye from Benzenediazonium chloride. So condition is alkaline condition, which is dilute sodium hydroxide condition, and the main reagent for this reaction is phenyl or its derivative, or naphthalon. Naphthol. This is particularly called naphthol, not naphthalon, naphthol. Okay, so here we have applied naphthol, we have reacted Benzenediazonium chloride with naphthol to give this azodye. Okay, okay, so that's pretty much it for this solution. So fellas, in this video solution we have seen the reaction scheme for making azodye from benzene. Okay, so fellas, I hope that this has helped you in your study, okay, for the preparation of your exam. So fellas, in the next video we gonna see the reaction mechanism of nitration of benzene.